Okay, so this is the partial sum of an arithmetic sequence. Partial sum of an arithmetic sequence. And so the key is the formula. And so we've got to understand the formula. If you'll remember, n is the number of terms, right? So you have n there and n there. And so a sub 1 is the first term. And then you have a sub n, which would be the last term of the partial sum, right? You know, our example, we're doing 50, so it would be the 50th term. And then you divide by 2. This is going to sum the first 10 terms, the first 40 terms, the first 80 terms, the first 2,000 terms. However many you need, it'll sum them all up. The formula will take care of that for you. Okay? So all we've got to do then is be able to sub into the formula. Okay, so here's normally how you do a problem like that. Like this. You're going to start with your formula. So I want S of 50. All right, and so n is 50. So where the n is, I put a 50. All right, a sub 1, I clearly see the first term is a negative 4. So that's a sub 1. Plus, and now when I get to a sub 50, I realize I don't know a sub 50. So I don't know that, but it's the only thing I don't know. So the only thing I don't know is a sub 50, and I'm going to have to find that. And this would be normally the way you would go about understanding the problem. So how am I going to get a sub 50? And hopefully you're going to think of the explicit formula. A sub n equals a sub 1 plus d times n minus 1. So I can find the 50th term with this formula. Okay, so let's go ahead and run it. So the 50th term will equal the first term, negative 4, plus, do you remember what d is? D is the common difference. How much is it between each term? And you can see that there's a difference of 3 in every term. So 3 is d. Again, n is 50. We're doing the 50th term minus 1. Okay, so let's figure out the 50th term. 3 times 49 is what, 147? Minus 4 is 143, right? So 143 is the 50th term. Good, let's put it right here. That's where I needed the 50th term. And now I'll just finish this off. So what is it? 25 times 139. 25 times 139. And I get 3,475. So if you add the first plus the second plus the third all the way up to the 50th term of this sequence, guess what? The sum will be 3,475.